Hello everyone and welcome back. My name is Purya and in this video we are going to show you a more practical and more advanced use case of Inmanta by configuring multi-vendor eBGP between Cisco, Juniper and Nokia. But before jumping right into the video and start configuring the devices, I want to shout out to our friend Roman at Containerlab. I have received your sticker, so thanks for that and thanks for the amazing software that you have created. Okay, what are we gonna do in this video? I have a Containerlab topology here. Let me quickly show you, which is consisting of a Cisco router at this IP address, and the type is XRV, a Juniper one, which is a VMX, and a Nokia router, which is the SROS, and they are connected exactly like this topology that I'm having here. First things first, let's go ahead and deploy the lab. How do we do that? We go to the folder that has the topology file. In this case, this is my topology file. The command would be sudo clab deploy tag t cbci demo.yaml, and there we go. If I make it a little bit smaller, it's easier to read for both of us or all of us. Okay, I'm on a very beefy machine right now because this Cisco router is a little bit nutty and requires a lot of resources. The entire process to have all these routers booted up takes around 20 or 30 minutes. And I'm gonna pause the video and get back to you once everything is booted up. Okay, after 30 minutes, the router should be completely booted up. Let's go ahead and verify it. And let's make sure you can see this too. Here we go. So my Cisco router is at 206. The Juniper is at 207 and the Nokia is at 208. Let's go by order and check the initial config and let's see if there's anything there or not apart from the initial config. So SSH, the user for Cisco is CLAB. If you remember from the previous videos, the IP address is 192.168.10.206. Okay, show run. Nothing there apart from the interface configuration that I have put in place already. Let's also check the Juniper. That one is at 207 and the user is admin. Yes. Okay, show configuration. And there we go. Nothing apart from the interface configuration. Very well. I guess we get the point and no need to go and check the same thing on Nokia as well. Since I'm done with this machine, I'm just gonna close this tab here. And we go back to our development machine. If you notice, I already have my development environment activated as well. And now what we need to do is to create a new environment. Let's go to my web console. Here we go. We are building on top of our previous videos. So you see Cisco, Nokia and Juniper here. However, I want to have a new environment for my eBGP examples. So let's create a new one. It belongs to examples. I'm gonna name this eBGP and submit. Let's go inside to settings all the way down. Let's copy this here. Now one thing that I would like to show you. Let me go back to my editor here. I happen to be inside the Juniper folder. Here, if you remember, in the past, we used to push the config or export our configuration to the server via running the export command. Let me actually show you. I guess that's easier. Tag E, something like this. We would choose the file that we would like to export to the server and then we would specify this environment ID. I'm actually preferring to have this in a file, and so that I don't provide it every time that I'm running this command, and it's gonna give me a better and more readable history if I have to check something. So how do we do that? There are multiple ways. We can use Inmanta CLI, or we can use or manually create a .inmanta file and put this environment ID there. Let me go back to my VS Code. Here inside Juniper folder, I'm gonna create a new file, call it .inmanta. Inside of here, I'm gonna open my brackets and say config, and down here I'm gonna say my environment is equal to this one. Save the file, and there we have it. Next time that we go ahead and push or export the configuration to the server, we don't need to specify this tag E and then the environment ID anymore. Anyway, if you remember our 6th video, which was introduction to Inmanta language, you remember how we used the power of Inmanta language to reduce all the duplication that we had for the BGP configuration. And in today's video, I'm gonna expand a little bit on top of that and use Inmanta language now to integrate all 3 vendors that I showed you here to achieve the same topology and configuration, but this time it's just a vanilla BGP. We are not doing any VRFs, we are not doing any kind of VPN, anything, just a vanilla BGP connection between these vendors. For that, since I didn't want to bore you to death, I have gathered the examples that we had already and I have modified them a little bit. However, I'm gonna put them in chunks and explain it to you so that we are both on the same page. Let me go back to my editor. Let's close this, we don't need it. By the way, this is the example from that video for Nokia. If you remember, we made an entity which was getting a name, management IP and neighbor IP, and then we had a BGP implementation for it, which was pretty small, and then we went ahead and used them like this. We gave it values like this and we implemented it. Now we need to do the same for different vendors. So let's go inside the main file. I'm gonna grab and put all the modules that we require here. Here we go. These are the modules we need for BGP configuration. Nokia, Cisco, and Juniper. By the way, we had some questions like how we got to like this structure, like how we decide, okay, there should be a group, there should be a family. These examples that we are showcasing here are corresponding to their respective Yang models. So whatever the Yang model is showing, we are just replicating on like that and following the same rules. So if something is looking weird or looking kind of like extra, that is the reason. This is not something that we choose. However, we could choose. Anyway, we tend to follow the standards. Okay, back to the main file. What do we need here? We need to define a router entity. In this case, we are going to call it a provider edge. Let me also grab it and put it here. Here we go. We are having a name, a vendor, which is of type vendor, and quickly I'm going to explain that as well. A management IP address, management port, username, password, the neighbor IP address, the local autonomous system number, and our peer autonomous system number. Okay, this vendor, I would like to use this provider edge with different types of implementations, and my deciding factor on how to go ahead and use which implementation for which vendor is gonna be this. I have 3 vendors: Cisco, Juniper and Nokia, and I'm gonna make a type definition here explaining the same thing and adding a rule here. Let's grab this as well, put it here. Here we go. So this vendor is pointing to this vendor here. It's a string, and it should be either of these values that I'm having here. So if you provide any values other than the ones that we have defined here and you're allowing here, the compiler is gonna prevent you and it's not gonna compile. What else do we have here? If you notice, we are having a local and peer ASN, and they are also having a AS number type. This is something that we should also define. I have it here as well. Let me grab it, put it here. There we go. It's an integer, and it should be equal or greater than 1 and less than or equal to this number here. Where do we get these numbers? If we can go to Wikipedia, on autonomous system page, we can see these values. And by the way, these are the 32-bit values. All right, let's go back to my editor. Let's start with Nokia, since we have something for it here as well. If you remember, the Nokia here is using the VPN type for BGP. I don't need that one anymore. I just have a vanilla configuration here. Let me grab it all and paste it here. Let's quickly go through it together. So we can say the implementation name is Nokia BGP, and it is for provider edge for this entity that we have here. Let's also make some space here to make it easier to read. Here we go. It is almost identical to the examples that we had, just a little bit different. If you notice, we are not having that VPN type anymore. Okay, now let's go ahead and get Juniper's. Copy, paste. Same thing for Juniper. We have named it Juniper BGP, and it is for provider edge entity. Almost identical to the example as well. Here, however, we have chosen to go with the virtual router instance type instead of no forwarding. I believe we were using in that example, or what was it? Let's actually check it since we are here. BGP VRF. We were using VRF in that example. Now we are using virtual router. Okay. We are using this interface inside of it. We have named our group eBGP group. We have defined the type as external, so it knows it's eBGP. Here, as you can see, inside of local ASN, we are referring to the local ASN of provider edge entity. We are doing the same for the IP and peer ASN as well. And the same is true for Nokia. Let me also grab Cisco's implementation. Here we go. Cisco's implementation is a little bit longer because the Yang model is kind of crazy. Okay. It's also again the same, almost the same as the examples that we showed in the previous videos. Here we have defined the router ID as 1234. This is my loopback interface IP. And we are having our update source as loopback. The previous one was Gigabit Ethernet 0. And we are specifying that it is a eBGP multi-hop so that the other routers can reach to us and we process their requests. Okay, this is it for the implementations. Now, how do we go ahead and deploy this? Let me actually close this here, split this, go all the way up. Okay, if you remember, I mentioned that we are gonna decide which implementation to use based on the vendor. How do we do that? Let me get my conditions here. Here we go. So we are telling the compiler to go ahead and make a model for our provider edge entity here using the Nokia BGP implementation if self.vendor is Nokia. And you see the same goes for Cisco and Juniper. Now let's actually see an example. Let me get Nokia's. Here we go. We are having a Nokia router. Actually, let's make some space here as well. Okay. We are having a Nokia router. The name is Nokia. This is the agent's name. The vendor we have defined as Nokia, this vendor. So whenever we go ahead and deploy this, we know we have to use this Nokia BGP implementation. The management port IP address, username and password, the neighbor IP, local ASN, and the peer ASN. This peer ASN is referring to Cisco's. Now it's Juniper's turn. Let me also grab that and put it here. Exact same thing, just the IP address is different and the name and vendor. And obviously the local ASN is different here as well. However, the peer ASN is similar to Nokia's because ultimately we are connecting to Cisco, which is running on BGP ASN 101. Up until this point, we've been dealing with one-to-one relations. Now we reach Cisco, which is having two relations with Nokia and Juniper. Clearly, we cannot take the same approach. So how can we solve that? How about defining another entity to help us in this case? So let's go here and say entity peering. And we are going to put everything that is required to form a neighborship with another router here. Let's just construct a body. What do I need for my peer? I need this field here and then the peer ASN. So why not just shift them down? Let's grab them and put them here. Perfect. Also, let's do some cleanup. So these implement statements that I have here are for provider edge. So let me just grab them from here and put it beneath it. There we go. Now we need a way to link these two entities together, this provider edge and the peering. Check this line out. This is how we do that. Let's see what it says. It says the provider edge entity can have 0 or more peerings. But a peering entity can have only one provider edge or belong to only one provider edge. All right. Another thing we need here is an implement statement. Implement peering using std none. So we don't need to have a separate implementation for this entity. That's why we are resorting back to the safe default, which is inside of the standard library. All right. If you noticed, we are having some errors already. on the provider edge entity, and that is because the peer ASN and neighbor IP are not part of this entity anymore. So let's go ahead and fix it. First, let's put them together. Now I need to instantiate this peering entity here. So peerings is equal to peering, just like that, and now I'm just gonna shift them here. Let's indent them as well. Here we go. We need to do the same thing for Juniper. So I'm just gonna copy this and put it here. Let's remove this and this. Perfect. All right, the error is gone. Also, we have to do the same for Cisco. Let me just quickly grab all of this, paste it here. This is gonna be Cisco. Okay. 206. The port in my case is 22. There we go. The local ASN is 101. Now here for Cisco we are having two neighbors. So I'll create a list. Just like that. And here we go. Now here I'll duplicate this. All right. So the first peer is going to be 10, 1, 1, 2, which is Juniper, 102. The next one gonna be 10, 1, 2.2, and the AS is 103. Let's click save. Now we also need to change the implementations. All right, let's do it actually from here. So how do we iterate over these values that we have defined? Extremely simple. We define a for loop. Let's say peering in self.peerings. Self.peerings is referring to this peerings that we have defined here, specifically for this Nokia. Now let's indent this. Also, let's close our loop. The IP address should point to the IP address that we have defined here. So it's gonna be peering.neighbor IP. Also, we do the same thing here. That's it for Nokia. Now let's go for Juniper. Repeat the same thing. There is one more thing here. So in the previous model, the remote AS was just a number that we really didn't care about because we are specifically specifying this number in the implementation that we have. I'm just gonna provide a number here, like 103. But it doesn't really matter. Okay. Now that we have saved, let's see if we can compile the model. Terminal. Inmanta compile tag f main.cf, and the model compiles. Let's export it to the server. Here we go. Let's go to the web console, and the resources are being deployed. So since this is the first time that I'm pushing this model to the server, we are gonna go download all the Yang models from all these routers and then compile those Yang models, which is a lengthy process. I might speed up or pause the video and get back to you once it's done. Okay, the deployment is done, and now it's time to go and check the configuration and BGP state on our routers. How about we start with Cisco? Need a new tab. Let's SSH to 192.168.10.206. Okay, show run router BGP. Here we can see our BGP configuration. Now let's check the status. Show BGP neighbor. Here we can see the Juniper. The state is established. Also, we should see Nokia's. Here we go. And that is also established. Let's go and check it directly on them too. Admin 207. Yes. Show configuration, display set. Here we can see the BGP configuration as well. Let's verify the state. Show router, show BGP neighbor. There we go. This is our neighbor, which is a loopback IP address of Cisco, and the state is established. Very well. Now let's check it on Nokia too. Exit from here. Yes. Okay. So for this would be admin display or admin show configuration. What do we have here? Let's go with units. We go down, here we go. This is our BGP configuration. Now also let's view the state, show router BGP neighbor. Here we go. You can see the peer and the status is established. Okay, so this concludes our video. In the next one, I'm going to show you how we can use Inmanta with a free and open source model that we have, which is for Vias. I'll walk you through how to get the Vias container and how you can use Inmanta's language and deploy the configuration on those routers and see it for yourself, all for free. I would like to thank you for viewing and see you in the next one. Bye.